Okay, so we have graduated block three. It's this thing up here. So now we will be looking at block four, which starts delving into hypothesis testing, which is way more interesting than confidence intervals. And that is for one simple reason. And I'm putting this so early in the video because it is the quintessential or like one of the best things you're gonna get from these videos. So I'm gonna put it even in big because I learned how to do titles. How about that? If the oops, if the P is low, reject the whole. That is one of the funniest things I've ever learned from a math class, first of all. But it is the best way to remember hypothesis testing or any ANOVA or whatever you're looking at. Remember, when the P is low, reject the whole. So what exactly does this mean? Uh, and as you can tell by my voice, I'm really enjoying telling you guys that. So in hy okay, you're not the annotate, are you? So, oh wow. Uh, Let me annotate. So in statistics, you have your null hypothesis and your HA. If this lets me annotate. It is not. So how about we just do it on here if I can clear my drawings. So in stats, you have two things. You have your HO, which is your null hypothesis, and you have your HA, which is your alternate hypothesis. We don't prove anything in statistics. We don't um, say, oh, the HA is true or the HA is false. We just reject or fail to reject. So um, I'm pretty sure the teacher gave this example when it comes to prisoners. So um, yeah, I don't know the example for certain, but um, you never uh, say, oh, the HA is true. You just fail to reject it. And you never say the HA is true. You just reject the HO. So this all revolves around the p-value, which is the probability. So if you see it here, you have your p-value uh, and your alpha. So if say you have like an alpha of 0.05 and your p-value is 0.03, the p is lower than the alpha value. So what do we do there? We reject the whole. And this is a yeah, a really vulgar way to learn statistics, but that is the best way to remember when to reject the null hypothesis. So when the p is low, reject the whole. And I am very sorry, but trust me, you're gonna remember that. I remembered it, so just run with it. I'm gonna say it a couple times, and that's what I do whenever I'm doing any ANOVA hypothesis test. When the p is low, reject the whole. So we're first gonna be using the histogram we used in our first review session for block three. So I'm literally just gonna copy that. I'm just gonna alter some values. So we're gonna do our 75. Scale is gonna be 15, and our size is still gonna be 100. I don't like that. That's better. Because as you can see, it has a similar bell curve. So we can start, uh, we can assume it is similar to normal. So here I'm, so this is a sample. So this is a sample. This thing here, you took a sample. So so your mu, so your population mean would be 75. And your sample mean, so your X bar would be NP dot mean of x. So that is the distinction. And for example, in this one, I don't know why it gave me red bars, but here you're trying to say HO is that your mu is equal to 75, and HA is that, let's say mu is different. So for fluidity's sake, or no, let's do, because I'm basing this a lot of teachers' examples, so let's just use what she uses. So here, the log here, that is your population mean from where you took the sample, and your scale, in this case, is 15, so that's your sigma, your population standard deviation. So for some reason, this did not run, or it's giving me, that's strange. I don't know why it's giving me that. Uh, yeah, I don't know why it's like that. Okay, it doesn't matter. So the checklist is kind of similar to the one of confidence interval in the fact that you need an X bar, you need an adjusted sigma, your standard error, your t statistic. But in this case, we're not looking at confidence intervals. We're going to try to calculate your p-value. So let's make again our little checklist. So we have our, let's do S, SE. That is a horrible S and T stat. Let's just do TS because I can't be asked to type that, and we need our p-value. P-val. Va Okay. So we have our X bar. What do we do next? So since we're using means, we need to adjust our sigma for, that's why it was giving me the red, because I had put a space before it. So we need to adjust our sigma for the degrees of freedom. So we do MP, so we do our S is equal to NP dot mean dot X, and we do DOF. This is equal to 1. So then with that, and we can do n is equal to len of x. Just let me make sure that the n is working. No, why is that not working? Give me 1 second. So yeah, it was another typo for me. So as you can see, our len is equal to our size, but it's just easier. So then we have our standard error. So we're going to do S divided by your NP dot square root. Since we're using means, we only take the square root of the denominator. Or sorry, one sample. Means we only take the square root of the denominator. So once we have all of that, so let's just get our standard error. So it's 1.51. We're going to get our t-stat. So our t-stat is, again, x minus mu. So divided by your standard error. So in this case, it is x bar minus 75, which is your predetermined mu, divided by your standard error. So here you can see our checklist. So we have our x bar, have our adjusted S, have our standard error, and we finally got our t-stat. So what do we do next? So since this distribution is normal, we can use scipystats.cdf. So we do pval equals scipystats.t.cdf, where I think it's x. No, give me 1 second. I'm looking at the formula. So yes, it is our x equals our t-stat because we're telling it where it is in the distribution. And then we do degrees of freedom equals n minus 1. So this, careful with this one, because further down the line, if we use this same formula and we're using a data frame, it might get confused. So that's why sometimes, and like further down, like in ANOVA and whatnot, they label data frames database, so DB. So in order to not spaz out your Python. So let's do tstat and your pval. So if everything runs, it is telling you, oops, pval. So it is telling you that your p-value is 0.4185. So we did not determine, but let's determine it right now. Let's say our alpha is 0.05. So something you can do is, and I'm going to pause. So something you can do to make your lives easier um, is just using if statements. You can see if you fail to reject or you reject. So as you can see, our p-val, I'm actually going to print it real quick so you guys can see it. Let's see if that works. Yeah, so as you can see, and I'm going to delete my annotations. Your p-val is greater than your alpha. So you can see it there, that 0.4185 is greater than your alpha value. But what happens if, say, I'm just going to copy this so you guys can see it. So let's just adjust that here. Let's take this out. And let's say our p-val is 0.01. What happens then? You reject the whole. So your P is low, reject the whole. That's how it looks in if you do not have enough evidence to prove the HO, you reject it. So next up, we're going to see how to do this, but with SMW in order to make our lives a lot easier. So as with the confidence intervals, SMW makes everything a lot cleaner. So you have to define your alpha first. Then you do res equals SMW is stats W, and then we're going to do of X. So here you do, give me 1 second. I'm just copying the formula. So I'm just going to delete that. Here you have to get three different things: your t-stat, your p-val, and your degrees of freedom. So here in value, you're going to do 75 because that's the mu value you chose. So you do res dot t-test because since we're using means, we're doing a t-test, and your alternative is smaller. So we're telling it that, hey, by the way, um, we're trying to see if our mu is smaller than 75. If we said different, I'm pretty sure you'd use two-sided. Um, and same goes for if we're trying to see if it's larger, where you would use larger. I'm not sure. Verify this on your own. So I just went ahead and copied this from the teacher. This is not something um, you need to do or know, just not needed. Uh, because this is just to make everything look prettier and easier for people in class to understand. This is the main chunk of what you need to know. So you run it, and there's an error. What happened? Give me 1 second. It turns out I'm not the only one who makes spelling mistakes. The teacher had put here Z stat. It is T stat because we're using degrees of freedom. So as you can see, your p-value is 4.19, and you failed to reject your null hypothesis, H0.